Then please write your name in the public chat, and then we will go through the questions one by one. Yes, Markus, you can unmute yourself and then go ahead and ask your question.
Hello, can you hear me?
Yes.
Okay, I have a question regarding the variables in the subroutine that are given. For example, in exercise 3, there are the integers I, j, and k. Do we have to use them all? Because I didn't and it works.
Okay, so if you might have to use them. So when you are programming or solving this exercise that I gave to you, there's always multiple options to reach basically the final result, and the integers are there to provide you the indices that you would be using if you do the computation in a loop. So for example, when you are computing, in that case, let's take the very beginning. You want to initialize, so the question in that exercise is you want to compute the sign of h, which is a 3x3 matrix, and before you compute this, this should be initialized with all 0 values. So you can either define every entry of these 9 entries to be equal to 0, or you can also do this in a loop, and this is what these variables are for. So these variables that you find in the beginning of the subroutines are they are a suggestion. Maybe that's a good explanation. It's a suggestion what variables could be used, but if you don't need all of them and still reach the goal, that's totally fine. If you need an additional variable because you think that you want to do the computation in a slightly different way, then you can simply add it. So that's up to you. In some cases, it's so if you haven't, for example, if you haven't done the computation in a loop, in some cases it's nicer to compute to compute certain steps in a certain way. For example, if you have to do a certain operation over and over and over again, and you always do the same thing, then it makes sense to do this in a loop, because then you're less likely to make mistakes, and also the code is more readable. But that's up to you.
Okay. And I had a problem with the faculty function.
Okay.
Because in my program, it only returned the value 1, no matter what I input.
Oh.
So I changed, I think the input parameter was a double, I think. And I changed it to be an integer, and then it worked.
Okay, let me check. Okay, if it's possible, could you copy what you changed and post it into the public chat so that I can see what exactly you changed?
Yes.
I remember from the last years that we sometimes had trouble with this faculty function. However, I didn't check the functionality in that sense, but maybe there's a modification.
No, I have to type it because I'm in the big blue button on my Windows, not on Ubuntu, so I can't copy it. Take some time.
Maybe you could also do a screenshot and then share this screenshot, so I could maybe that is.
I'm halfway through.
Okay, then we'll wait. Rajesh, I remember in the exercise you are saying there was an I missing. In the exercise we modified the function so that it is taking it is not using the function dint to make an integer out of the input, but idint. Let's see what Markus has changed, and then see whether this is related or whether.
So the input was a double, I remember.
Mm-hmm. Okay, so now you have the input, you have a... Okay, I just noticed there's obviously different versions, because in my code that I have in front of me, it's also slightly different. Okay, so you changed that I is not a real variable, or a double variable, but an integer, right?
Yes.
Okay, and probably you don't mean I because you're using I as a counter here, or do you mean no? You mean J from 1 to, but the input is N. Oh, okay.
Yeah, okay, I changed J to I. Yeah.
Okay, I see. Possibly. So what we did in the, maybe I can copy what we have done in the. So what you should have from the. This is, I think, what we discussed in the exercise. So here, the variable, what is n in your case, you apply the function idint to it and save it to jend. So it is basically it's transferred to an integer as well. Possibly it does the same. I have to check because as I mentioned before, I didn't check the functionality of this version, but I will let you know. But so now with your version, it is working and it's returning the correct faculty value.
Oh, it's idint. In the Moodle course, in the file, it's only dint.
Yeah, this is the change that we did in the exercise. This returned. So in the last years, somehow when compiling, it didn't return the error. And also actually, if I compile it with a compiler on my notebook, not in the Ubuntu, then it also does not return an error. But with the compiler installed in the Genie and for Ubuntu, it returns an error. So this is why there's this inconsistency.
So it doesn't return an error; it just returned the value 1 every time.
Okay, so actually, when I was compiling it in Ubuntu, in the Ubuntu environment, then it returned actually an error. It used dint already, but I will check this so that we have the correct we have a correct solution that you can use in your program. But so you are saying, so you changed it so that you have an integer, and thereby it is returning the correct value. Okay. Okay, any further questions, Markus?
No, that's it. That's it.
Okay, thank you. Any other questions from the rest of the people who are attending? Yes, Miklas, you can unmute yourself and ask your question.
Yeah, ma'am. Am I audible?
Yes, I can hear you clearly, thanks.
Yeah. So I have written the code for all the exercises, subroutines which I have stated. And I was able to compare the code for the exercise 2, like computing the H power 4 using the direct computation and using the spectral decomposition. So I got using the Cayley-Hamilton theorem, and the results were I got the same results. So that seems to work fine.
Okay.
But I'm facing difficulty with the third exercise, computing the sine function.
Okay.
There is no error shown in my code, but when I try to compute the results are very different.
So the results are different for what? So you get an answer, but it's just not the correct answer.
Yeah, because the results for the sine functions from spectral decomposition and the results for the sine function from the power series are different.
Yes, but this is not an error in your programming, I suppose. This depends strongly on the extent to what you compute your sine function with your power series. So you have the variable counter max, which is basically setting the limit up to which you are computing your power series. And you can basically check the accuracy of your result when you look at the sum of sine square and cosine square in the exercise 3b. Because if you take the analytical values, this should be equal to 1. So I suppose most likely if you increase your variable counter max, then your results will get more close. If that's not the case, maybe then there is still some error in the program, that some variable is actually not computed correctly. But maybe this is what you could do to check.
Okay, so actually, just now after you said, I checked my cos square x plus sin square x for the spectral decomposition, and as you said, it is 1. It's like the identity matrix.
For the spectral decomposition.
Yeah. For the spectral decomposition.
For 3.
Sorry, ma'am.
For exercise 3.
Yeah, for exercise 3, cos square x plus sin square x using spectral decomposition, it's as you said, it's coming 1 identity matrix.
Okay, and how about for 3b?
For 3b, it's very different. Like currently, my counter is 5. It's like 20. The counter is 5, so I'm using like h power 11. I'm using like h power 11. So it's very different. Like it's like 20, 21, like that it is there.
Okay, try to increase the counter.
Okay.
Try to increase the counter and then check your result.
Okay. Can I just do it now?
Yeah, you can do this, and then maybe I will take the next question.
Yeah, definitely.
You can check whether this changes.
Yeah, I will unmute then.
Okay. So, are there further questions? Chandra, go ahead.
I did the coding, but I'm getting some lot of warnings and so many errors. But I don't know. It is like showing end of the file is missing and subroutine somewhere it is showing so many errors and warnings.
Okay. Could you please share your? So I have gave you presenter rights, so you could share your screen, and then I have a quick look to see what might be going wrong. Okay, can you go to the very first error? Okay, you are in that line. So EV actually is a variable. Okay, if you go, if you look into your code, EV is the variable which is containing your the eigenvalues, and in line 329 you are trying to reach to get access to this variable, but you are not you don't say like I want the first, the second, or the third entry, but you have the index I1 here, so it simply cannot access the variable in the way that you are. Do you understand what I mean? So imagine EV is a vector. EV is a vector containing 3 values, okay? The first, the second, and the third value. And if you say, okay, I want EV in brackets 1, then it's returning, it's like a function. It's giving you back the first entry for the bracket term equal to 2. It's giving you the second one for the third one, and so on. So that's basically how this works. Now you are trying to get the, so I1, I suppose, is some real number. So it's not an index referring to one position in your vector, but it could be anything. It could even be the value like 2.5. And what would be there is no 2.5th entry of a vector. So you would need to modify that line.
Okay.
Maybe you can go to the next arrow, and we have a quick look what that could be. Okay, legacy extension real. Can you go down in the errors? Mismatch. Okay. Maybe this takes a little longer. So I would suggest that we first. So we put your questions on hold. Okay. We will have a look at that later on. But first, I would like to ask whether there's any further general questions.
Okay.
So to the rest of you, is there any further general questions related to the exercise or the lecture? Maybe while you are thinking about some further questions, I can inform you what I have, what are the news in the Moodle course related to this computational inelasticity course. So I would like to start with some programming in FEEP, either in the next week or in the week after. And therefore, because I'm not, I would like to know what your experiences in programming and also especially in using FEEP are. You should have learned about how to use FEEP and how to program finite elements in FEEP. You should know this from your finite element foundations course from the last semester. However, since I know that the last semester was not like all the other years before, I would like you to, I would like to know what your experiences here are. And maybe I can share my screen, 1 second, to show you what I would like you to do. So I also sent you a message through the Moodle course, but what I have created here is a feedback module, let's say it that way. It's called Programming Knowledge and Experience in Fortran and FEEP. So it's basically a form which contains several questions. It's anonymous, so if you answer some questions, I cannot I do not know who answered what in this feedback form. There are several questions on your current knowledge, how to use FEEP, what you have, what you know, what you have done in your previous courses already, or what you maybe know from your current courses. So I would like to ask you to fill in this form. It would be best if you do it as soon as possible, so that I know about your knowledge in FEEP and in Fortran. The reason why I would like to know this, the reason why I would like to know this is because I'm already reading in the public chat that there was no FEEP exercise in your course in the previous semester. Still, maybe we can talk about this later on, but still, so you please fill in the form so I get an overview on what you know and what should be provided in this course, because to give you an outlook on what I would like to do with you in the exercises and in the lecture. So in the lecture we will discuss several formulations for materials which describe phenomena which can be summarized under the term inelasticity. So you will also see that in today's lecture video. There I give an introduction to some inelastic phenomena. So you know, I think from your previous studies, and the most simple case of a material law that can be considered is Hooke's law, and there you have just a linear relationship between the strains and the stresses. And when this relationship between stresses and strains gets non-linear, there are several material behaviors for which this is true. For example, you can have nonlinear elastic material behavior, but you can also have a material behavior which you can have damage, for example, inside your material, and there's models to describe that. Or you can have effects like plasticity in your material, and there's also material models to describe that. And to make this long story short, the aim of this course is that you learn about these models and you learn about the mathematics and the thermodynamical modeling, what is behind this, and you know how to implement these. And therefore, I want to use the finite element program FEEP, but therefore you need to know basically how to work with Fieb, you need to know Fortran programming because Fieb is written in Fortran. And you basically need to know how to handle the how to handle the different files or modules which are provided in Fieb. Okay. So you are saying there was no Fieb exercise in the previous semester, meaning you only had lectures on where you used Fieb in the previous semester, or didn't you get to see anything about Fieb at all? So maybe, I don't know, you can type, any of you, whoever wants to answer, you can type the question in the public chat, or you can also just say it in the room. Yeah.
Yeah, ma'am. The previous semester we were having FEM, but there was only lectures because the corona was there, and we only had online lectures. And only one Fieb introductory part was uploaded, but that day the Moodle was Big Blue Button was not working, so there was no exercises, nothing. They just uploaded that part, and we went through that. One introductory part was uploaded. There was nothing exercise, nothing else.
Okay, so you have never worked with Fieb on your own, and you have never programmed in Fieb or created an input file or completed a finite element code, nothing?
No, ma'am. FEM foundation, the previous semester was mine. I think so many people were there with me, FEM, and we were having only lectures the previous semester.
Okay. Okay, that is good to know, because then I can, okay, so you were told about the basic idea of input files. I'm just reading in the...
And also, they uploaded the files and we did it by our own. There was no one, taking exercises or, that. There was nobody. We did it of our own.
But you did you have exercises to complete on your own, or what did you complete on your own?
No, it was an introductory part, just the Fieb handout and all. Just to read, there was supposed to be a lecture, exercise actually. And Swartz was in vacation, and there was someone else was supposed to take. But the Big Blue Button was not working, and then we had no exercises, nothing.
Okay, and that wasn't a repetition of this missing exercise?
No.
Okay.
Again, after that, we started with lectures.
Okay.
Yeah.
Okay. All right. Okay, I will think of... okay, this kind of messes up my schedule, but we will handle this. Okay, I will provide some additional learning material for you with which you can catch up on the on what you should have learned in Fieb, programming, of creating an input file, and also creating a finite element code. So you know, I mean, what you have learned in the lectures in FEM is basically you start from the differential equation, you derive the weak form using the Gayorkin method, and you discretize this, and you formulate your discretized problem with the stiffness matrix and your unknown variables on the right-hand side. So this is what this is basically. I mean, this is what you should have learned in the lecture, and in the exercise, or what you should also know is how do you program, how do you put this into a finite element code? How do you implement this into Fieb? And I will create for next week, I will take one of the exercises from the FEM course. And with that, we will go through what you missed in the last semester. I will provide the material probably this afternoon or tomorrow, so that you can have a look and prepare until next week. And I highly recommend that you have a look at this before. I will try to provide you with some tutorial video which you can watch and then try to complete the task on your own. And then we will basically catch up on the knowledge in the next week, and then the week after we are doing the exercise on nonlinear elasticity, which I was planning to have in the coming week. Okay, I think this is a good idea because otherwise I think the exercises will be very, very difficult to follow, especially in this online format. And I think this is not a very good idea. But I think maybe in that way we can handle this issue. However, I mean, you hear this probably all the time, but especially in this situation, I have to ask you to really prepare the exercises and also the material, the content from the lecture very well, so that we don't lose time in the exercise due to someone not being prepared. Okay, so this is what I would really like to ask you to do. So I'm going to provide you with some extra material, but it is your task to work with it and to learn FEEP with it and to prepare the exercise as well. FEEP is programmed in Fortran, so if you are not so familiar with Fortran, please check some online tutorials or some examples which give you an idea on how to use Fortran. And additionally, I can show that to you as well. From yesterday, so I uploaded this yesterday. You can find here under the module tutorial videos and additional material a PDF file. So this is the PDF file that was only existing in German before, which we translated now to English to make it easier for you to read. So here you have, if there are still typos inside, please don't look at those too closely. But this file should give you an overview. Do you see the file? Wait a second. Now you should see the file. In this file, it's a Fortran introduction, and it gives you the most important information on how to program in FEEP. There's some example programs. For example, this very well-known Hello World program, which simply writes Hello World to the screen. But I think this gives you a good idea on how to program in Fortran. And in there's a section on loops, for example. And there's also some applications here. And for example, one part, I think, which is dealing with vector matrix or matrix vector operations, so the multiplication of matrices and vectors. So this is basic knowledge in Fortran, but I think this is more or less all you need to complete your programming exercises in in this course. So please have a look at this if you haven't done this yet. And if you feel that you need even more material, then I would suggest that you have a look at the internet. Maybe there's some nice tutorials on YouTube or something. I haven't checked that yet, because I think this gives you a very good overview already. But that could be another option. Okay. So, and again, reminder, please fill in the feedback form so that I know about your knowledge. Okay, back to the question whether there's questions from your side related to the exercise. Do you have any further questions? Okay, I don't see anyone typing or unmuting him or herself, so I assume that there's no questions left. Chandra, you can stay in the room and we can have a look at the problems that you...
Hello, ma'am.
Yes.
Yeah, can I also stay? I just wanted to show the code which was after increasing the counter.
Okay, you can also stay. Then we will discuss those two issues just in the small group, because I don't think that everyone needs to maybe not everyone's interested. Okay. So whoever is interested can stay. I don't have anything, any arguments against that. And for the rest, you can leave the room, and then we will meet again next week for a live session in this Big Blue Button seminar room for the exercise, and I will upload the material for you well ahead of next week so that you can prepare. Yes, and then we will go through the basics on finite element method and FEEP to give you a good start into the programming in FEEP. Okay. So thank you for your input, for your questions, and I will. You will find the uploaded stuff also for today's lecture in the Moodle course. All right. So, Chandra, I will stop sharing my screen and give the presentator rights to you so that you can share your screen. Okay, so this one error, we talked about that. So now there's a problem with exercise 2. Can you go down? In the program, yes. Mm-hmm. Further down. Further down, I would like to see the subroutine exercise 2. Okay, can you go up a little bit to the initialization of the variables here? Okay. You have commented everything here. So the error occurs because you in your subroutine. So you put a comment everywhere to be able to compile. But when you put the comment here in line 356 to 359, then it doesn't know the variables H, H4, H4, KD Hamilton, which it needs for the in and output. So if you simply delete if you uncomment the lines 356 to 359, this should solve the problem, the error that is occurring here. So you are just it's then just declaring the variables. It's not carrying out any computations, but it needs to know these variables because they are the in and output of your program.
Okay.
Okay, can you go further down? I think the next errors are all related to this one as well, and
I think all this related to this one only.
Unused dummy argument on 2 and 1. Can you go up a little bit? To the input of your of this subroutine that we were just looking at. So the input of dyadic EV. So the very top where it says subroutine dyadic EV.
Subroutine dyadic EV.
Okay, maybe you can recompile your program because now you have removed some errors and maybe some of the
Now it is finished successfully. Still some warnings are there, man.
Yeah, the warnings are, so for example, when you look at the last warning, it tells you that you have not used a certain variable.
Yeah.
It's simply telling you have declared too many variables and you are not using them. This is not so nice from an efficiency point of view for your program, because when you are declaring variables, you're using disk memory, or it's taking up disk space, and if you are not using them in your program, then it's making it inefficient. But this does not create an error or something in your program. So if they are simply warnings, then probably this is related to that fact.
But warnings is okay, right, ma'am?
Warnings, I mean, it would be perfect if you can remove all those warnings. That means if you are not using a variable in your code, then you should not be declaring it in the first place.
Okay.
But for now, if you simply have warnings, but your code compiles fine, then you can simply leave in these warnings.
Okay, ma'am. Okay.
Yeah.
Yeah, ma'am. Thank you, ma'am. Ma'am, I also had one more doubt. Like while initializing every matrix, we need to write like a loop is enough, or we can write like individual elements?
That's up to you. You can decide on your own. I like it better when it's in loops, but it's up to you. Okay. If the result is correct, then you are free to do it in the way that you want.
Okay, ma'am. I also had one doubt while doing the quizzes, online quizzes. Mm-hmm. I don't know whether it is correct or wrong. Like I am not seeing what is correct. Like answer. I did first quiz, but I don't know whether it is all correct or all wrong. Like that.
Oh, okay. I will check the options in the quiz whether it is showing you the correct answer in the end, and then if it's not, then I will modify this. Okay.
Okay.
So it should be showing you when you're answering incorrectly, then it should show you the correct answer. But I'm not sure whether whether there's a setting that needs to be changed for that. But thanks for the feedback. I will check.
Like I'm asking about like if I finished all the cases, like 7 questions, like I should know now whether it is which one is correct, which one is wrong. Like if I submitted.
Yeah.
That one I want that one like that. Is there any possibility.
What do you mean? So you get the result when you submit?
Actually, I am not getting the result. That is the problem.
Okay.
Like my question, like if I submit the program, I should know now how many questions I get correct, how many wrong, like that.
Yes. Okay. Let me check with the quiz whether there's an option that needs to be modified so that you see the correct or the incorrect result. Maybe the quiz works in such a way that you answer all the questions and then you submit and then you get the result and it tells you what was wrong and what was correct, and then you can redo the quiz. So I set the option that you can do the quiz as many times as you want.
8 times, no?
Yeah. So I will check this right after this meeting, and then you can try again maybe tomorrow. Until then, this should be solved.
Okay, ma'am. Okay, fine, ma'am. Thank you.
Okay.
And also, I had one more doubt while regarding submitting this, in text file, we need to print only output, right? First text is output, second output, third output.
Yes.
Okay. With this input file, right? Two.
Yes. So you should send me the filled in Fortran file, so invariant theory.f, with which you computed the results, and then just copy from the terminal. You can just copy it to a text file and then send that file as well.
Okay, ma'am. Okay, ma'am. Fine, ma'am. Thank you very much, ma'am.
Okay, thank you. Are there further remarks or questions? Okay, if that's not the case, if there's no further questions, then I would be closing this. Okay.
Yeah, ma'am. Can I share my screen?
Yes, 1 second. Now you can share your screen.
Is my code visible, ma'am?
Yes.
Actually, I have checked the first exercise, and I have compared the invariance, and the invariance seems to be correct, and the eigenvalues are also correct. But I was not able to check the dyadic product. I have written the code, but I have not able to confirm whether it is right or wrong. The dyadic product.
Okay.
And after that, I did the second exercise, and second exercise it is correct because I have checked the output, and the outputs are matching. Both outputs are matching, so it should be correct, I guess.
For the second exercise?
Yeah. The computation of H4 using the Cayley-Hamilton theorem and using the direct method. So both are matching. So second exercise is correct. Third exercise, as you mentioned a few minutes ago, it's the third exercise part A. Here using the spectral decomposition, it's correct because sin square h plus cos square h is coming to be 1, identity matrix.
Okay.
So as you mentioned, it is correct. But for the third exercise part B, this is the code I have written.
1 second.
Yeah.
Yes.
And when I try to compute it, I'm not able to get it's not converging. And if I increase the counter value above some 50 value, I'm getting an error. Segmentation error, something like that. Should I show my output for the third exercise now?
Yes, that would be helpful.
Let's compile. see the output, ma'am?
Yes.
Yeah.
Okay, can you go back to your code, please?
To the 3B exercise?
Yes. Can you go down a little bit? Okay, stop.
Yeah.
There is a problem with your H powers. Can you can you mute yourself, because otherwise I'm getting an echo, and that is quite confusing, because I would like to explain what is. Okay, so please go back to your code. Okay, so when there is an error in your computation of H powers, so you can compute H based on the spectral decomposition, and that would be simply the loop that you have here with the where you have well, maybe I can so what you are so you need one additional so okay, this first of all this loop is not computing what it should do. Okay, so if you simply I will now show you in the public chat. I will show you the code with which you can compute H, so the matrix H. And that is this one. You see here that you have, so you need 3 loops. You need 2 loops because they are running over the dimensions of the matrix H, basically. Actually, the M should be, okay, I made a mistake in here. It should be this way. It should be this way. So I and J run from 1 to 3 because this is the dimension of H, and then K is the summation index, which is doing the summation for the spectral decomposition, because you have the sum over all eigenvalues times the dyadic product. If you want to compute now the powers of H, what you need is you need to add another loop which is taking care of the exponent. Okay, and what you would be doing there is you would simply use a 4th loop outside your computation that I have shown you in my previous chat entry. So you see here that you need 4 loop counters. You have IJK, which we saw already before, but you need another one, M, which is then running from 1 to whatever exponent you want to consider. Okay, and here you see I have EV K to the power of M, and what you had in your code is EV of I to the power of I. Okay, so basically you are so there's something going wrong. If I is running higher than 3, then it cannot access EV I, and also the index of the eigenvalue and the exponent, they should not be the same, okay? Do you understand what I'm trying to say?
Yes, ma'am. Yes, ma'am.
Okay. So this is what is missing for you in this computation of H powers, and based on that, of course, the sine and the cosine can't be correct.
Yeah, yes, ma'am. Yes, ma'am. Can I just confirm the dyadic product, ma'am? Because I still have doubt also with the dyadic product. Can I do that? Dyadic product?
Yes. Mm-hmm.
I will try the things which you mentioned in the exercise 3B.
Mm-hmm.
And regarding the dyadic product, this is the code I am using for the dyadic product.
Mm-hmm. So I can compare with. So I assume that your computation of the dyadic product is working fine, because if it were not working fine, then you would not get the correct result in exercise 3. Okay. You can also try to. You can try to evaluate the sign of one entry of your matrix, basically by hand, by applying the sign function, and thereby check whether you get the correct result. However, I'm going to check with my code that I have here. So this looks good. The only thing that you should change in line 130 is that you put you have the factor 2 and the exponent 2. You should put 2.d0 in both places to make sure that you are using 2.00000 and that it's not taking some junk from the memory. Otherwise, it looks good. So I think I had to look at this, and if you didn't mess up something in the adjungate, then it should be fine.
Okay, ma'am. Can I go further?
1 second.
Yeah.
Okay. You can go further.
Yeah. I was just curious about this H2CH. This is the H2CH, like finding the H using the spectral decomposition.
Mm-hmm.
So this is a formula actually. This is a formula which is given in the notes, in the lecture note. And when I compute it, I will like to show the. Actually, as I mentioned earlier, there is no need for me to compute it because these are matching. Direct and the matching. This is just out of curiosity I was trying to do. And if you could see, okay. And also this is a problem. When I try to debug something, usually in MATLAB I just print out the thing so that I know where I'm going wrong. So here also I try to do the same thing. I try to do this command, print command, but when I do that, it's coming like this. It's not coming in a matrix form.
Yes, you can. If you go to the top of your Fortran is a very old programming language. The 77 stands for the year that this was invented. Okay, so actually, it is not as user-friendly as MATLAB, but you find the commands to do the output in the very top. For example, here with the write, you could simply copy this write command that you have here for whatever matrix, and then put it to the place where you want to check your output. So that would be one option.
I did it, but when I do it, it's not updating. It's like showing the what is the initialized value that is being displayed. Like H2, every element is 0, 0, 0 when I did it.
Can you show what you did?
Yeah, I just.
Okay. If you do it in this position, if you look at line 80, you are calling the subroutine exercise 2, and it's only exercise 2 is only returning H, H4, H4CH, so it doesn't know H2CH.
No, I included H2CH here also, and I included H2CS even in the top also.
Okay, then
here
try this, and then.
Okay.
And you also need to include it in your subroutine. So where it says subroutine exercise underline 2, there you also need to include that.
Yeah, I did that now. Actually, it's not showing any error, but the values, it's not updating.
You need to include it also for the subroutine. So go to the place where your subroutine exercise 2 is computed.
Yes, ma'am. Yeah.
A little further up.
Yeah.
The very beginning where it says subroutine exercise.
Yeah, I had included it, ma'am.
Yeah, but no. In line 360, it says subroutine exercise 2, H, H4, H4CH. Here you need to include it as well.
Okay.
This is the only place, this is basically the only thing that you are communicating back and forth. So the main program does not know what the subroutines do. It only knows what the subroutine tells the main program.
Okay.
And this is only what you put in the brackets here. So if you try now, it should work actually.
Yeah, ma'am, it's working now, yeah.
Okay, perfect. Yeah, so you need to include it really at all these positions, because otherwise the program simply, the subroutine does not return the value, and then it cannot be printed.
Yeah.
Okay.
Yeah, actually the question was, the question was these two values, these values which I'm underlining, this is 18 and 18, right? But the actual values should be 14 and 14. Supposed to be. I tried to check the code 2-3 times, but it doesn't seem to be working.
Okay, can you go to the place where you are computing that? So one thing that I'm seeing is you say EV to the power of 2. So you should put 2.d0 here. However, I don't know if this is going to solve the problem. Maybe you can try?
Yeah. No, ma'am.
Okay, and it should be 1414, you say?
Yes, ma'am. I checked it with the version, and it's 1414.
Okay, 1 second. you go back to the JKI. Can you remove this to the power of 2, what you have in H2CH right now, so that it's simply computing H? Okay, and the original okay, so this works fine. Are you sure that there is not an that there is not an error from
because this is the H2 value, ma'am.
yeah, can you go to the, where do you compute H2?
H2. Also, I computed H2 manually also, I checked it. So, this is H2.
Mm-hmm. This is funny. Okay, it's difficult to try to look for the error now in this like online setting.
Yeah, actually, I just wanted to know the debugging so that I could try later. So thanks.
Yeah. Well, I mean, with a print now, you could continue to debug this. I would say check again your eigenvalues should be correct, and your dyadic product and dyadic n also looks okay because it's displaying the correct value for the matrix H itself, if you just do it in this way.
Yeah.
So the last test that we did. Right now, so based on what I see, I don't have any another suggestion for you. Try to debug, and if you really can't find anything, then you can send me your code, and I will have a closer look to try to find the error.
Yes, ma'am. Yes, ma'am. Actually, I was trying to do this because I had a doubt with the powers, because I was struggling with the power.
Mm-hmm.
So I thought first I will at least try to solve for H2 so that I can build on H3. But now that you have told me where is my mistake with the powers, I will do the powers first and I will get back.
Okay, yeah, that's a good idea.
Yeah. Thanks, ma'am.
Okay, you're welcome. All right, now last chance for any further questions. Okay, no questions. Then I would like to thank you for your attendance, for your participation, and then have fun with the lecture material. And if you want to submit your exercises, please remember to submit them until tonight. And then I hope you have a good rest of the week. And I'm looking forward to seeing you next week in the exercise. Thank you and bye-bye.
You are currently the only person in this conference.